Hello everyone, welcome to Simplified Geometry. Today we are going to see Theorem 6.3 of lines and angles. This theorem states that if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Let us understand this theorem by looking at this diagram. Here, line L is the transversal. This transversal L intersects line M at point P and it intersects line N at point Q. We are now concerned with the interior angles only. So the interior angles lie between these two parallel lines. These inside angles are called the interior angles. These angles lie between these two parallel lines. So angle 3, angle 4, angle 5 and angle 6. These are all the interior angles formed here. So now we are concerned with only the alternate angles, alternate interior angles. Now where are these angles located? Angle 3 is on the left side of this transversal. Okay, angle 3 is on the left side of the transversal and angle 5 is on the right side of this transversal in the bottom side. So angle 3 and angle 5 will form one pair of alternate interior angles. We will note that here. So angle 3 and angle 5 will form one pair. Angle 4 and angle 6 will form the another pair of alternate interior angles. So the theorem states that if any one of these two angles is equal, it can be either this or it can be either this. If any one of these angles is equal, then we can say these two lines are parallel. Okay. So for example, if angle 3 is equal to angle 5, here angle 3 is equal to angle 5, then automatically line M will be parallel to line L. It is as simple as that. This is what this theorem states. If angle 4 is equal to angle 6, then again line M will be parallel to line L because these are alternate interior angles. Now let us take an example. Here line PQ is a transversal. This line PQ intersect line AB at point R and it also intersect line CD at point S. Now it is given that angle ARQ, this angle ARQ, this angle is given as 170 degree. And angle PSD, this angle is also given as 70 degrees. Okay. We want to check if these two lines are parallel or not. We want to check if these two lines AB and CD is parallel or not. Okay. See, a Z shape is formed here. Here, a Z shape is formed. Let me highlight that. See, in this part, here you can see the Z shape, right? We already know that this Z shape stands for alternate interior angles. See, in the inside corners of this Z shape, we have the equal angles 70 degree and 70 degree. So alternate interior angles is equal. So these angles are equal. Let us write that. So the alternate interior angles are equal. From the theorem we just learned now, we can conclude that AB is parallel to CD. What is the reason? The reason is that these alternate interior angles are equal. Since the alternate interior angles are equal, these two lines are parallel. This is the parallel line symbol. AB is parallel to CD. So this is how we use the theorem. Since this is a theorem, it has a proof. Now let us look at the proof of this theorem. So given that two lines A and B is given and line PQ is the transversal. So line PQ, the transversal PQ intersect line AB at point R and line CD at point S, such that a pair of alternate interior angles is equal. So the proof, we want to prove that if the alternate interior angle is equal, then line AB is parallel to CD. We have to prove that these two lines are parallel. That's the proof. Now let us write the given information first. So we have written the given information. And what you have to prove? You have to prove that AB is parallel to CD. We have to write this part also to prove part. Okay. So let us look at the proof. See, for lines AB, for lines AB and PS, you can see these two lines, right? For lines AB and PS, angle 2 equal to angle 4. Do you know the reason? The reason is that angle 2 and angle 4 is a pair of vertically opposite angles. See, lines AB and PS intersect at point R. So we know that the pair of vertically opposite angles are equal. So angle 2 is equal to angle 4. Let us write that. So angle 2 is equal to angle 4 since vertically opposite angles are equal. This is the reason. Let us name it as equation 1. So in the given, it is given that angle 4 is equal to angle 6. This is given. So we will write that here. Angle 4 is equal to angle 6. So angle 4 is equal to angle 6. This is given information. We have to write the reason also. Now let us name this as equation 2. Okay. So from 1 and 2, you can observe one thing. Angle 4 is here and angle 4 is here. So from 1 and 2, angle 4 and angle 4 is in common. You can see that. So automatically angle 2 will be equal to angle 6. Okay. So let us write that systematically. We can write this equation as angle 6 equal to angle 4. So from both these equations, angle 4 is in RHS. Again here also angle 4 is in RHS. So automatically we know that the LHS will also be same. Angle 2 will be equal to angle 6. What's the reason? Reason is from equation 1 and 2. Now we just proved that angle 2 is equal to angle 6. But in the diagram, what are those angles? Angles 2 and angle 6. These are nothing but the corresponding angles. We have learnt earlier that angle 2 and angle 6 are just corresponding angles. We just proved that these two are equal. Okay. So angle 2 and angle 6 are corresponding angles. Okay. So for lines AB and CD with transversal PQ, we just proved that angle 2, the corresponding angles angle 2 and angle 6 are equal. We just proved that. So automatically these two lines AB will be parallel to CD. What's the reason? The reason is converse of corresponding angles axiom. From that only we can say this. Am I right? So the corresponding angles are equal. So line AB will be parallel to line CD. Therefore, line AB will be parallel to line CD. So what's the reason? We have to write the reason. Hence we proved the theorem. So we will write hence proved.